We're going to continue now looking at another statistical value that we use to describe data, the mean. And this is our third measure of central tendency, where we looked at the mode and the median previously. Now we're looking at the mean, which we can describe as the sum of a set of values divided by the number of observations in that set. So we'll look at that a little bit more here in just a moment. First, I want to kind of take a quick moment to refresh your mind on the order of operations when we're doing things like algebra or any mathematics, really. So think back, hopefully this is not something new to you. You recall it from your math classes in the days past. And you remember, hopefully, that number one, the first thing we do is look for any parentheses, be them regular parentheses, brackets, square brackets, curved brackets, any type of parenthesis. We evaluate those first. And if you have parentheses or brackets within one another, you start with the one most in the middle, the one contained the most, and work your way out. So you do parentheses or brackets first. Those are going to come before everything else. And then sometimes you'll have to go through that order of operations again within a set of parentheses or brackets. And then number two in the list, so the thing you do next is exponents. So if you have any exponents, you do those after anything within parentheses. Then after that is multiplication and division. So any type of multiplication, any type of division, no matter how it's represented, you do those next. And then following that is addition and subtraction. So once you've done everything else, then you can add or subtract. And remember, if you have any order of operation or any of our things on a level here, if you have multiple of them, you work left to right. So if you have multiple exponents, you start with the leftmost and then just keep working to the right in your equation or in your formula. Likewise for multiplication or division, interchangeably, if you have multiplication, multiples of that, if you have several times you need to divide at the same level, and by level I mean, parentheses levels, so you could be working within one set of parentheses and have to work left to right doing some multiplication and division perhaps. And then outside of that set of parentheses, when you finish that, you might have, more multiplication and division that you work left to right for. So remember, left to right when you're kind of on that same level, when you're doing some of the same stuff. Just work innermost out with embedded parentheses and brackets. So start with the ones contained, the most and work your way outwards. One other piece of information that you may have had, hopefully, and you may need a little bit more refreshing on this, is sigma notation. This thing you see here, it kind of looks like an E, an uppercase E, but very pointy. This is the Greek letter sigma in its uppercase form. And what this uppercase sigma represents is that you need to take the sum of whatever follows it. It's a shorthand for, summing things up. And we have some information sometimes above and below that Greek letter sigma. So if you have something below, in this case, n equals 1, that's telling you start, for any n you have following it, start by substituting 1 in there. And then next you'd go and through the whole thing again and substitute 2. And each time you make one of these substitutions, increasing your integer value by 1, so 1 to 2 to 3 to 4. Each of those times when you take and substitute something in for n, you find that result and you save it, you do it again, and then add those up. So this is where the summing comes into play. Each time you substitute in for n, you figure out that number that results, and you add that to your sum. And the number on top then, in this case, I put 4, that is the highest integer that you're going to go to. That's where you end. So in my example here, I have the sigma from n equals 1 up to 4 of just n. So maybe take a moment, pause the video, try this out on your own, see what you get as a result, and we'll compare. And so if you paused, let's resume. So n equals 1, we just substitute 1 in for n, and that's just 1. So we take that, hold on to it. We substitute 2 in for n. So that's just 2, it's just n. So we've got 1, we've got 2, and you can see where this is going. We go all the way up to 4, so we end up with 1 plus 2 plus 3 plus 4. Because ultimately we're taking the sum of the result of each of these things where we substitute, in our number in for n in this case. And we figure out that the sum, sigma of n, where n goes from 1 to 4, is 10. So take a moment, let's do a couple practice problems here. So I'll leave you to try this one. Pause the video. What you do, remember sub in, substitute first 1 in for n here in this formula and solve it. Find a number, save that, then go back and substitute 2 in for n, find the result, store that away, and we're going to do this all the way from n equals 1 up to n equals 4. And so if you've paused and resumed, then what we have here is 3 plus 5 plus 7 plus 9 equals 24. And see where I got this from. First, if I put 1 in for n, I have 2 times 1. We do multiplication first. So I get 2 plus 1 is 3. And then I move up to n equals 2. I substitute 2 in for n. I have 2 times 2 plus 1. So I do the multiplication first. 2 times 2 is 4, plus 1 is 5. And you can see where I substitute 3 and 4 in for n in order to get this result. Likewise, another problem, very similar, except n equals 3 all the way up to 5. Pause the video, try this on your own. Note that there are some parentheses here. So give it a try, and then resume and see if your result agrees with mine. So resuming your video here, resuming this example, if we substitute 3 in for n, this is where we're starting, we get 3 plus 1, because we have our parentheses first, that's 4, and then multiply that by 2 to get 8. And then we substitute 4, so 4 plus 1 is 5, times 2, we get 10, so we'll hold on to that and then substitute 5 in. 5 plus 1 is 6, times 2 is 12. And we've reached 5, so that's all we need to do. And this gives us a sum of 30. So the sigma of 2 times, in parentheses, n plus 1, from 3 to 5 is 30. So returning to this concept of mean, we can also call this the arithmetic mean or the average, and this is going to be usually the most appropriate to use when we're using interval or ratio scale data, so not nominal or ordinal in most cases. We use this when we want the average, and using our sigma notation here, you can see that our x with a bar over it, that means we have some variable x, and the bar over it indicates that that quantity is the mean. That is equal then to sigma from now I equals 1, so we're using i's and we're starting at 1 all the way up to some value n. And in this case, n represents the total number of observations we have. And we're doing that for x with the subscript I. And in this case, I is not something where we're substituting our value in and multiplying or dividing, but our subscript indicates, which data value we're using. So if we were to line all of our data values in our data set up, we have I equals 1. We take the first value, and then we add the second value to it for I equals 2. And we go and we go and we go, and we go from I equals 1 to n because we have n number of total values. So we go and add all the way up to the nth value, and note that we take the sum first, then we divide by n. So let's apply this then to our ranked class heights. So we have our 23 heights in inches, all ranked from lowest to highest. In this case, the ranking doesn't matter, but it's good to have to use. So remember before where we started, we found the median, and we had 1, 2, 3, 4. We looked at those in order. So we basically, if we're going to apply our sum here, and I recommend that you stop the video, try this out on your own, you'll see that we basically just go through each one and add each value together. So to get our mean, we go through that same formula. If you add these up, we get 1,577 as the sum of these 23 heights, and then divide that sum by 23, and what we get is a mean height of 68.6 inches. Now, a few additional kind of conventions that we're going to use here, beginning now and more often as we go into statistics. Number one, when we're using sigma, if you don't see, like I equals 1 below and some number above, if both of those are absent and we just see our Greek letter sigma, what this indicates is that, without those things, we're going to take the sum of all values. So, x sub I in this case, we know that we have some value x sub I, that could be the first value, the second, the third, whatever. What this indicates without the top and bottom stuff is that we're going to go through all of them from I to n. So I being 1 all the way up to n. We use this often enough that it's just not worth noting every single time. We can save ourselves the clutter and the trouble of including that. So a sigma alone means that we're going to go through every single value. And I use lowercase n here specifically because lowercase n's represent a sample. So this n, the small case n, is the sample size. Maybe we want to use my class of 23 students and their heights as a sample for the entire university. And the entire university, if I had that data set, I would use the uppercase n. So uppercase n represents the population size. Lowercase n represents a sample size. And I'll return to this later when we go over samples and populations in a bit more depth. Now back to the mean. If we use this knowledge that I just gave you, what here do you think the Greek letter mu represents? So mu equals sigma x sub I divided by uppercase n. And while you think of this, the big hint here is that it looks exactly the same as what we just looked at, except for that uppercase n and, of course, our Greek letter mu. So what hopefully you came to is that mu represents the population mean. So we use a Greek letter mu to represent the mean value of some population. And you could have guessed that perhaps by seeing that I used uppercase n rather than lowercase. So one final question here about mean. What is the primary difference between the population mean, mu, and the sample mean, x with the bar over it? So if you think about that for a moment, what we come to is that the population mean is never going to change because that's some population. But a sample we take can vary quite a bit depending on which observations we included in a sample. So samples can vary in that mean value, but your population mean is never going to change.